Uh, okay. I've got an important meeting I have to attend to after this. So I'm going to quickly go through the work. If I go too fast, please tell me, slow down. Okay. Last week when I was here, obviously I was here with a book and that's it, to give you an introduction lesson. Okay. Today is almost like an introduction, not as a lesson. Today is an introduction to this module. Okay, so we're going to discuss everything that we can do throughout the year, and obviously there's slides involved and stuff that you need to study. Okay, so it's a lesson, but it's still seen as an introduction to what we need to do, what we need to know for this year. Okay, just for those of you who wasn't here last week. Okay, one of you, two of you. Okay, so the people that weren't here, we've got class reps. Where's the class reps? Those are the class reps. Please make sure you put your names on their WhatsApp group. They've got a WhatsApp group. Classroom related queries, you go to them. Individual issues, you come to me. Okay. Then also, if you've got problems with your other modules, come to me. Okay. Go to your lecturer, sort it out with them. If you can't sort it out, you come to me for the high certificate stuff. Okay. Sorry, my brain is a bit confused. I've got so many things on my mind. I think you can hear that. Okay, that being said, we're going to quickly do the basics, basic anatomy and physiology. We're going to go through all those things. I actually said we need to do the cellular level today as well, which would be the first level of what we need to discuss. However, I've got a meeting that I need to tell you, so we're not going to do that today. This is a year module. I'm going to see you the whole entire year, so we have more than enough time to get through all these units. Okay. So something like today happens, it's going to happen most probably again somewhere. I'm not giving you the information, I'm not giving you the information that you need. Okay, we've got enough time to do all those things. Okay, that being said, people, there might be still other students that join us. They extended registration by another week. Okay, so that's also why I don't really carry on with all the work, and then next week I have to catch up with the other students if they do join. So this is another week of, I'm going to obviously give you lectures. We're going to lecture in your other modules, but also in lectures, but we're going to just discuss the basics. Okay. For those of you who weren't here last week, this is my office, that's my telephone number, that's my email address. The stuff is not on Moodle yet. I was waiting for them to give me access. I actually received an email this morning to say I do have access on Moodle. So the stuff that you see on Moodle, there are stuff over there. You will see the stuff over there. It's similar, it's really the same. Okay, however, the dates changed because it's 2026, not 2025. Okay, so the dates have updated. I'm going to update all those things within the next few days, and you will have access to all those things. With regards to these modules and these units, I'm only going to release them just before class or just after class. Obviously, you would like to see it before class because then you know what we're going to discuss. I'll see how it goes, but the issue with that is usually if I release it, say, a week in advance, students read through it and say, oh, I know this, I don't have to go to the university today, I'm just going to skip class. These classes are compulsory. Okay. Like I said, there might be some lessons if I'm somewhere away on a conference or something, where we might have an online class or an e-learning where I say, study this, come back with questions or something like that, but that will be communicated. The rule for this high certificate is actually 70% contact, 30% online. Okay, that includes online tests and assignments and submissions and stuff like that. Okay. So, again, if you've got an individual issue, you email me on that email address over there. You'll hardly find me on that telephone number because I'm not in office. I'm busy with lectures, I'm off campus, on campus, and all those things. But within an email, I usually respond within 24 hours. If I don't be shy, send me a follow-up. Say, sir, I sent you this email, please, can I have confirmation or something on the email? Yeah. Good. Unless it's a weekend, then I'll only respond on a Monday. Okay, no prescribed textbooks needed for this module. You will have your study guide, you will have your slides available. Okay. People, we do go into slightly detail on certain topics and certain things. But if you are in class, you will know what's important and what's not important. Okay. You're not becoming doctors. You're not becoming a general practitioner or a surgeon or something like that. We are coaches. You need to understand the basics of anatomy and physiology. Okay. Good. So, anatomy and physiology, what is this? Anatomy is described as the structure of the body, what it consists of. That vessel that you are in, the subject should be easy because you live in your grip note for your tests. Okay. Physiology, the structure of functions and anatomical structures, individual and cooperative functions. Meaning, for example, if I eat a hamburger, how my body uses that as fuel. That's physiology. How my body takes oxygen molecules around me, how I breathe it in, and how that is used when I take part in a certain sporting code. That's physiology. So, physiology happens only the second semester. Now we're going to discuss anatomy. Okay. So anatomy, you get gross anatomy, macroscopic anatomy, which examines the large structures of the body. Okay, and this is what we're mostly going to look at. Surface anatomy, regional anatomy, systemic anatomy, clinical anatomy, developmental anatomy. Those are the different ones. We're just going to look at the gross anatomy, your function of the skeletal system, your skin that you're in, the cardiovascular system, the respiratory system. All those things related to sport, we're going to look at. Okay. And we'll touch on the other ones. There's 11 systems in the human body. We won't do all 11 systems because it's not really linked to certain sporting codes. Okay. Okay. Furthermore, just to elaborate on that, anatomy, microscopic anatomy examines the cells and molecules. We're definitely going to do the cellular system. We're going to discuss the cellular system. Why? Because all your other systems in your body links back to the cellular system. If we do physiology, how your body uses fuel on a cellular level with your mitochondria, meaning your energy yielding aspect of a cell. That's why the cellular system is important. If I think of your muscular system, how you get to that word where they call muscle memory, where you think my muscle remembers certain things, where it's actually satellite cells hanging around, giving your muscles more energy or going back to the normal state. Go back to that specific type of training and lending mitochondria and so on over to the other parts. That's why that is important. That's why we're going to do the microscopic aspects of the cell. Then physiology, cell physiology, how they divide, how they use, organ physiology, systemic physiology, functions of specific organs, functions of organ systems, and obviously pathological physiology. Not really going to go into that. We will discuss certain diseases and illnesses which relates to certain sporting codes. For example, if you don't have enough red blood cells in your body, what can you do? If I need more red blood cells because I'm a high performance athlete, I need to do altitude type of training. We will discuss stuff like that. Okay. Please, if you read these words, don't think it's difficult. Okay. I can't give you a synonym for that because that's what they gave me. That's what it is. It's really not difficult. We're going to do the basics. For you, when we're done with this module at the end of the year, you need to be able to stand on the field, look at a person taking part in the sporting code. Say, for example, they do a 400-meter sprint. You need to know what systems are at work. You need to know what muscle groups are at work. The basics of it. Why they breathe. Why they breathe more. Why they build up lactic acid. All the basics required in that individual taking part in the different events. And then you can break it up into soccer or rugby or whatever it might be, the sporting codes that you're going to use. Okay, so just quickly, these are some of the systems that we're going to discuss. We've got like the digestive system, how you eat food. Why is that important in sport? Because you need to know what fuel you need to consume, what macronutrients you need to consume, what micronutrients, macronutrients, carbs, proteins and fats, micronutrients, vitamins A, D, E and K, and water-soluble vitamins, vitamin C and your B vitamins. Those type of things. Why do I consume them? Why are they important? When should I consume them? How long do they take to go through my digestive system? Okay, again, we're going to do it basic. I will give you a scenario. You've got a person, I'm just taking an example now, he runs a 5,000 meter on the track. Okay, you know, for example, he needs carbohydrates. How long before does he need to consume the carbs? And what happens if he consumes a bowl of pasta before he takes part in the event? Tell me, explain the whole digestive system and where it gets absorbed and so on. So that's important to know for your different sporting codes. Then obviously, like for example, the respiratory system, which is your lungs, how you breathe. All sports require that. Whether you do chess, you need to breathe to play chess. You need to breathe to relax. While you're sitting here, your respiratory system is important. We'll discuss that. Then the cardiorespiratory system, your heart and your lungs, and how your heart, how it pumps the blood through the body, how it links with your respiratory system. And all this urinary system, we will touch on that. Okay, we don't really go into detail on that. We will touch on that. Integumentary system, what is that? Your skin. The largest organ in the body, your skin, and everything that's on the outside. That's also important in a sense. For example, if you play certain sporting games where they bump and they bruise you, where you can identify maybe a certain injury that's involved, so you can still take part, or no, you need to rest. Okay. Small stuff like that. That's why we need to know all these things. Okay, so levels of structure in the body. The smallest level in the body is obviously atoms. Atoms, they combine with one another and they form cells. Okay, that's where we get to the cellular level. Now in the body, with all these different cells that you do have, they've got different functions. Cells group together to form different things. For example, if you think of your bicep in your arm, that's a lot of atoms forming cells, those cells forming this muscle fibers. And there's a specific cell in a specific structure to form that. Then if you think of your heart, which is completely different compared to your bicep, again, atoms form cells, those cells form your heart. Does that make sense? Okay. So cells, and those cells, they form the different tissue, they form the different organs inside your body, your kidneys, your heart, your liver, and all those things. And then these organs together form organ systems. The heart and the lungs, the respiratory and the cardiovascular system. Okay. And then obviously all the organ systems, all 11 of them combined, forms you as a person, or organism. Okay. Does that make sense? So those are the 6 levels of structural organization. Atoms, cells, tissue, organs, organ systems, and the organism. Okay, so like I just discussed, these are the 6 systems. We get the atoms, which everything is on a chemical level. Now, why do we refer to the chemical level? Physiology. Okay, physiology, where your energy comes from. How it's broken down into the basics of the basics, where your body uses certain, again, oxygen to do certain tasks in the body. Okay. Cellular level, obviously different cells form different things. For example, if I think of the skeletal system, you get cells which is called osteoblasts and osteoclasts. We'll get to that. They only form by impact on the body. So if you run a lot, or you jump a lot, or you lift heavy weights, it's impact on the body, and your bone structure grows bigger because of it. Okay. Then you get the tissue level, the different tissues. Like I said, the skeletal system is a tissue, your biceps, your skin, all the different tissues form together to form that, and form cardiovascular system and all these things, and your blood vessels and all that. Okay. Everybody still with me? Until we get to the organism level, which is you as the person. Now, obviously, there's a lot of different organisms in the world, but we're only discussing the human body with regards to anatomy. Why? Because that's what you're going to actually work on one day when you go out into the real world. I don't think anybody of you will be coaching horses or dogs or something like that to take part in sporting games. That's not why you're studying this. Okay. So just to elaborate on what we just said, levels of organization, the chemical or molecule level. Atoms are the smallest chemical units. Molecules are grouped into atoms, and they work together to form certain aspects where they form cells. Okay. I'm not going to go through all that again. I'm just touching on it. Set all this. Okay. So just major organs in the unit in your body. Okay. Well, let's touch on those. Organ systems. Integumentary systems. Okay, this is the outside layer of your body, your skin, your hair, your sweat glands, your nails. Okay, what's the functions of this? Protects against environmental hazards, helps regulate body temperature, provides sensory information. That's why the skin is important for all those types of things. Why is this important in sport? Why are we discussing the skin in sport? Just for basic, sweating. If you don't sweat properly, you don't cool down properly. If you don't cool down properly, you can't perform properly. And that's stuff that you will pick up. Okay. If you sweat too much, you lose too much water mass, then you have to consume more water. So that's why this is important. So now you need to understand how this works and why this works in that certain way. So you can link it with your sporting code when you get there. Then you get the skeletal system, the skeleton of the body. Okay. All the bones and bone structures. Okay. Major organs, obviously, bones, cartilage, ligaments, and the bone marrow. All of them play a very important role. Again, we're going to go into detail on all these things when we get to them. Today's an introduction to these systems. Functions provide support and protection to the tissue. If you think of your rib cage, it's formed like this for a reason. Because inside your rib cage, you get your heart, you get your lungs, you get your stomach that's down here, you get your liver, you get your kidneys. Everything's protected by your rib cage. That's why it's formed like that. Okay. Stores the calcium and other minerals. Why is that important? Calcium, magnesium, all those minerals, electrolytes. Why is electrolytes important in sporting codes? The salts. Why do people get cramps in sport? Because they don't have enough electrolytes, for example. Why do people sleep bad at night? Because they don't have magnesium in their body. So we're going to look at all these different things and go into detail on that. Why that is important. Okay. For example, again, the bone marrow. What happens in your bone marrow? You form red blood cells. What do red blood cells do? Oxygen. It helps transport the oxygen through your body. What can you not live without? Oxygen. What can you not consume your food or absorb your food as fuel without? Oxygen. You can't break down carbohydrates into glycogen without oxygen. You can't absorb glycogen without oxygen. You can't use glycogen without oxygen. You can't take your fat storages and use that as energy source without oxygen available. So you need oxygen for all these things. You can't recover and repair. So you tear your muscle in the sporting code. If you don't have sufficient oxygen, you don't repair your muscle. Who of you have seen these chambers that they lay in now these days? It's like an oxygen chamber or oxygen tank. Why do they lay in that? Because it increases the recovery speed of the person or the individual. Okay, so those are all the things that we're going to look at with regards to that. And then you look at the muscular system, all the muscles involved in the body. Gastrocnemius, all these things, your calf muscles, your quadricep muscles, your hamstrings, your glutes, all those types of muscles. Okay. Obviously, there are hundreds of them. I'm not expecting of you to know all of them. I will still be going into detail. There's certain ones that you need to know. The big muscle groups that you need to know inside the body. The ones that if I'm standing here and I see my athlete participate, kicking a ball or throwing a hoop or whatever, those muscle groups, those are the ones that I need to know, need to understand. So I can see in my head, okay, they are doing this, but they're struggling with that, so this muscle group they need to improve on, or work on, or make stronger. And then obviously, with regards to the muscle, how they break down while taking part in sport. And then we'll link that with physiology, for example, if you say hormones play an important role in the human body with regards to recovery. Okay. I take part in exercise to actually tear my muscles on a microscopic level, to break my muscles down on a microscopic level. Then my body needs to release certain hormones and use certain aspects, amino acids and proteins and so on, to recover my muscles. And the quicker I recover, the harder I can train, and the quicker I can retrain again, and the stronger my muscles recover, and the better I become at my sport. So that's the type of thing we get when we get to the muscular system. Then obviously the nervous system, you know those jitters that you feel, if you blush, if you see your girlfriend or your boyfriend, or that feeling that you get if you're in love, it was Valentine's over the weekend, those type of things is all in with regards to your nervous system. Then you link that again with the sporting code. Why do they get nervous? It's called, I'm getting nervous before an event, before a game, before a match, whatever it might be. And how does my system, my nervous system, actually influence how I perform on the field? Okay, so within the nervous system, we look at the brain, the spinal cord, the peripheral nervous system, and all the sense organs. The touch, feel, smell, taste, all those things. And then we can also go into a bit of physiology to say, listen, if somebody struggles with being too nervous on a field, what can they do to lower their nerves to perform better? Okay, so that's why we do that. Then endocrine system. Endocrine system refers to all your glands inside your body. You've got glands in your neck, you've got glands under your arms, you've got glands at the back of it. It's all throughout the body. Okay, and how these glands have certain roles, mostly it's to get the toxins out of the body. That's actually what it is used for. So pituitary gland, pancreas, thyroid gland, adrenal gland, it shoots adrenaline, and so on and so forth. Okay, and what are they used for? When do you activate them? And how to activate them? Is there certain fuels you can use to activate them? So certain peptides, proteins that are broken down and developed into new strands that you can use to actually activate them, all these type of things. Then, obviously, the cardiovascular system, again, like I said, for any sporting code, heart, blood, and blood vessels. Don't get confused between the cardiovascular system and the respiratory system. They work hand in hand. So we go look at the heart and how the heart pumps the blood through the lungs, through the body, and how you breathe it out, and so on. A gas exchange takes place. Okay. Lymphatic system, all your lymph nodes, your spleen, thymus, all those things, how they excrete certain hormones. It's also important. This part over here, lymphatic system, not too important for you as a coach for a specific individual, but the hormones being released in the lymphatic system. The physiology aspect in regards to that is very important. Okay. So, for example, if you know about, okay, but this, I'm just speaking layman's terms now. But say, for example, you send somebody to do blood tests and you see their testosterone levels are really low. It can be part of the lymphatic system that might have an issue, and you need to be aware of that. Okay, then the respiratory system again, the nasal cavity, the sinuses, your larynx, pharynx, your voice box, all the things going down into your chest. Know all the different parts and what they are used for. Obviously, respiratory system, breathing, oxygen, gas exchange. Your diaphragm, how it pulls together when you breathe in, and how, for example, now if you think of people taking part in sporting codes, you will tell them, pay attention to your breathing. And what they will do is they'll breathe in and then they'll blow out. That just uses energy. If you just sit there and I say, breathe in and now relax, you're going to blow out anyway. So instead of breathing in and blowing out, using energy both ways, you can use energy only one way and save the energy, because if you just relax, your diaphragm relax, and then you just breathe out on your own. It happens automatically because of the compression in the air and the compression in your lungs. Yeah. Small things like that we can discuss. That's the respiratory system. Then the digestive system. Obviously, we said it's important to understand the digestive system because this links with physiology aspects as well. How you consume the food, how long it takes when it comes to for low GI foods or high GI foods, how it spikes your blood level sugars and how it lowers your blood level sugars, how quickly your body absorbs certain foods versus other foods, what food sources you require, and so on and so forth. And then obviously the organ system, it's the urinary system, okay, not as important for coaching per se, but we're going to touch on this just for you to understand how it works with your kidneys. If you've got not enough sugars, not enough salts in your body, or not enough fluids in your body with regards to water and stuff like that, and how the body excretes them, and what would happen if you don't have enough of that. So it's not too important in this part, but we will just touch on it so you've got an idea how it works. And then obviously the reproductive system. The main thing about the reproductive system that we're going to discuss is the hormones, the different hormones, male hormones, female hormones, testosterone levels and so on, and how they have an impact on the different sporting codes that you will have as coaches. Okay. Male and female reproductive system. Okay, and then maintenance of life, necessary for life functions. Okay. Stuff that you always need to do. Movement, locomotion, movement of substances. Okay. If you think of locomotion, first thing, that's you as a person moving around. If you ever go to a doctor and you get an injury, doesn't matter what injury you have, you tore your whole upper leg, you can't walk. If that doctor tells you go lay in bed for the next 6 weeks for that to go see a different doctor. Okay. Never ever, the worst thing that you can do, worse than eating wrong, worse than drinking alcohol, worse than taking drugs, is sitting still, not doing nothing. That's the number one cause of death in the world, doing nothing. Locomotion, you standing up, moving around, that's the most important thing that you can do. Even if you're a coach and you're coaching individuals that run the whole day and they need to run 4 or 5 hours a day, For them, sitting still for 4 or 5 hours a day, doing nothing. Me, sitting behind my desk 4 or 5 hours just typing. Very bad for the human body. You have to move. You have to move. And then obviously movement of substances, fuel ensures movement of substances throughout the body. So these things are required for life, necessary for life. The fastest way you die is if you stand still, sit still, do nothing. That's why you see people, they work their whole career, they wake up in the morning, they do the work that they need to do, they go sit behind the desk, they do their work, stand up, come home. When they're 65 years old, they retire. Now they're going to just rest. They wake up in the morning, they go sit on the stoop, they go to the room, they lay down and sleep. Next day the same thing, and the same thing. From 65 to 75 years old, they age 30 years and they die. Because the body stops moving. Okay. And then obviously, responsiveness, ability to sense changes and react within the body. There's a lot of things we're going to discuss with regards to that. But for example, if you age, you can't train the same when you're 27 versus when you're 37 versus when you're 47. You can't coach your individuals the same. They don't recover the same. They don't have the same hormone levels. They don't process the foods and they feel the same. Okay. Another response, for example, males versus females. If you think of coaching them in a gym, what it requires for a female to build muscle versus what it requires for a male to build muscle. Two different aspects. Then digestion, breakdown and absorption of nutrients, that you need to do always. The better you break down and absorb the fuel that you take in, the better you will perform. As simple as that. Metabolism, how your body works and the chemical reactions within the body, this is physiology. This is when we get to physiology. I'm not going to go, there's a thing that they call the Krebs cycle. That is your initial burst of energy that you have. Lasts around about 10 seconds. It's called the ATP-BC system. Creatine phosphate system. You don't require oxygen for that. It just happens automatically. That's, for example, if I tell you, stand here and deadlift 100 kilograms quickly. Pick it up. Takes you 3-4 seconds to pick that up. You don't need glycogen or protein or anything to pick that up. It's the ATP-BC system that works. But as soon as that's done, that first 6 to 10 seconds, then you go into your glycogen stores and so on. The carbs that you store in your liver and your muscle fibers. So metabolism, what is breaking down of complex molecules, builds larger molecules for smaller ones, produces energy, regulates hormones inside the body. Okay, so that is metabolism. How you sit over here and how you use your calories of energy that you have without doing anything. How fast that happens. How fast this breakdown happens. That is metabolism. That's what metabolism is. The faster your metabolism, the more calories you can consume without storing it as fat and be gaining fat. Does that make sense? It's your metabolism. You get a thing where they actually go sit in a lab. We've got it over here at the university. You sit in a lab, they put a mask on your face and you relax. And it can tell you how many calories per hour you burn as an individual. It differs for everybody. There's a calculation that you can do online as well where it takes your body mass, how active you are, and all those things, and you can get your resting metabolism. Okay. How many calories you consume per day without doing exercise. But to make it accurate, you actually go to your lab and do. Why is that important? Because, for example, everybody differs. I might be here, this person weighing 85 kilograms, and the same person weighing 85 kilograms, we do exactly the same thing for work, we do exactly my metabolism might allow me to eat this amount of food and burn it. This version of me, this amount of food and only use half of it. Store the rest because of my metabolism. Okay. And there's a lot of things with regards to that we're going to still discuss that plays roles. Okay. Then obviously excretion, eliminates of waste from the metabolic reactions. Waste may be removed through urine or feces, as you do know. For example, if you think of why is this important for, why are we discussing urine in runners or in sport? People, if you think of, for example, you say, listen, let's take supplements. You're not getting enough food in, you want to take a supplement, you want to take a recovery shake. You want to get protein in after your thing. You read on the label over there or on the box, it's amazing, it's 3,000 rand for this can because it contains 80 grams of protein per serving. Nice, it's a lot of protein per serving. It's 4 times as much as the other thing that cost me 500 rand. but now consume this, and my body can only absorb 30 grams of protein in this one sitting. And I literally poo out the rest of the protein without using it. So stuff like that you need to know with regards to your coaching. And then obviously necessity for life, furthermore, reproduction occurs in a cellular level, an organism level, produces future generations. Now when I say reproduction, I'm not just referring to reproduction of making more people, having babies. Reproduction of cells. Reproduction of red blood cells. Your red blood cells, got to say, a lifespan of 21 days. From a small red blood cell, it goes to 21 days and it starts dying off, but you need to make more. So within your whole life, your skeletal system, your whole life, and it slows down after, I think, the age of 30, but we'll get to that. It slows down, but your skeleton that you are born with, the one that grows until you're 80, that whole skeleton gets replaced by the time that you're 40 years old. Because your body makes the cells, depending on the impact that you have, and how fast it grows and all that, makes the cells die out, but your body makes new cells, and new cells. And the whole thing follows that circle of life, the reproduction. Okay. And then obviously the growth is exactly like I just said, increases cell size and certain number of cells. Thinking of this muscular system, people want to start doing bodybuilding. You are a coach, now you need to develop a training program for this individual. Obviously genetics plays a role, but cells. You don't really make more cells in a certain sense, more muscle cells. But you can grow those cells if you train them correctly for hypertrophy, for example, versus endurance. If you do a certain amount of exercises on a certain level with a certain time in between, certain amount of sets and so on, you will grow those cells. People call upon what they call satellite cells, cells that hang around. Then they come into, they lend their mitochondria and stuff for the cell that you do have. It becomes bigger and stronger, and you look more muscular if you do the correct exercises for that certain cell. Okay? So, and then increasing of cell size, for example, fat cells. Some people that are really big, okay, that have got a lot of fat mass on their bodies. That a big thing around that is genetics, because they are born with a certain amount of fat cells. Okay, you don't really make more fat cells. You can get rid of fat cells. You can kill your fat cells if you drink enough water. Your body can get rid of fat cells, but you can't really make more fat cells. The only thing that the fat cell does is it grows. It stores the fat and it grows. And it grows and grows and it becomes bigger and bigger and bigger. That's what a fat cell actually does. But some people say, I eat more fat, so now I've got more fat cells, so now I'm fatter. No, it's not like that. Okay. Genetically, you're born with a certain amount of cells that you can use for different functions inside the body. And then you see these things, what they call like those, I don't know if you've seen it, the fat freezing and stuff like that, where they actually freeze your stomach for an hour, and you go there every week or every second week, and you pay thousands and thousands of rands, and then it kills some of your cells. And you drink water, and you get rid of some of those cells. Okay. Other people go for that liposuction, and they suck out the fat out your body, and now you're skinnier. Okay, because you've got less fat cells over there. All good, friend. Well, if you do that, and you go back to your old diet, the cells that you do have left, they're just going to grow there. They're going to become bigger, and you're going to get exactly the same fat mass. Doesn't mean you can continue with your diet that you followed that gave you that nice big belly, and then you think, I'm going to go for this, it's not going to come back. It doesn't work that way. Why is that important for runners, or for sports, for all types of sports? Because the more you weigh, unfortunately, the more energy you need to perform certain tasks. Now, depending on the sporting code, if you are one of those strongest men, I don't know if you saw, South African won the strongest men champs last year. If you're one of them, they want to be big. But if you look at them, they're much stronger than the bodybuilder, but they almost look fat. Because they're big men with a big, but they're strong. Okay? So in that essence, they want to look like that. Then you get the bodybuilder that wants to lose all that fat, because they want to look lean, the paper thin skin. That's what they want, to show all their lines and stuff on their body. So all these things you need to know. If you think of runners, if you take a long distance runner, they want to be as skinny as possible, have as least amount of fat as possible. And I promise you, if you take that person, they've got less muscles, but if you take off their shirt, they are obviously lean, but they almost look a little bit fat compared to a sprinter, for example, which has got more muscle mass. But we're going to go into detail on all those things. But all those things are important when it comes to the physiology and how the body works for their specific sporting codes. Furthermore, survival needs is obviously nutrients that you need. The chemical for energy and cell building includes carbs, proteins, lipids, vitamins and minerals, as I did say earlier. Oxygen, the most important thing. Anything in the whole universe can't live without that. Then water, 60 to 80% of the body weight is actually your water mass. And have you seen Dricus, the UFC fighter? The day before he fights, they need to cut the weight because they need to weigh in. He loses around about 15 to 20 kilograms compared to the day when he fights, because he cuts water mass. So he lays in a sauna and stuff like that. It looks like two different people. If you remember, next week, if I've got more time, I'll quickly get a picture of you. Before, the day before fight and fight night. Before fight night, he weighs in at 89 kilograms. Fight night, he weighs in at 105 kilograms. Because that's just water mass that he cuts. It's very, very dangerous for the body, but he depletes himself completely of water because your body consists of 60 to 80% of water. So imagine you cut 50% of that. If you weigh 80 kilograms, you cut 50% of your water mass, you weigh 40 kilograms. If you just do that. Okay, so then we move over to the next part. Okay, obviously your body needs a stable temperature of 37 degrees Celsius. I think you know about this, you learned this in school. Again, important because you will see in certain environments, depending on where you're going to coach, you might coach somewhere where it's on altitude, where it's really warm, or you might go to a different place where it's really cold. And the way you put on clothes and stuff like that, everything plays a role in building on performance when you coach them. So that's why you need to know to keep the body temperature stable. Okay. All body systems working together, that's homeostasis. From the anatomical level to the cellular level, everything needs to work together. While you are sitting here as individuals, your whole body is working in synchronization. Otherwise, some of you will be sitting here and sweating like you've never sweat before. You will sit here and some of you will be shivering if your body was not working in homeostasis. Okay. All body systems working together to maintain a stable internal environment. How you sweat, how your heart beats, how you process your fuel if you ate this morning, all those types of things. Systems respond to external and internal changes to the function within a normal range. Body temperature, fluid, balance, all those types of things. A dynamic state of equilibrium. Dynamic, what does dynamic mean? It doesn't stand still. It doesn't stand still. For example, you want to keep your body static means still. Dynamic means movement. Okay. If you want to keep your body at 37 degrees Celsius, that's what your body needs to do. You're not sitting here and thinking 37, keep it at 37. It just happens. Okay, it's homeostasis that does that. Okay, keeps in equilibrium. But if I tell you to stand up, run to the stairs and come back, and when you get here, you're going to start sweating. You didn't think start sweating because I need to bring my body temperature down. It just does that. Now you sweat, that's your body's internal, what do you call it, air conditioning. So who have you felt that? If you sweat, you're hot, you sweat, but as soon as the wind blows, you cool down immediately. It cools you down. So that's why you sweat, to keep yourself cool, like that. So if this doesn't work when you coach one day, there's big problems. People come to you and they train and they warm up in this, and it's 30 degrees outside, but they warm up in a sweatpants and a sweat top because they're used to doing that, because it was a winter now. Now they want to do the same thing. When they start taking part in the event, they're tired. They can't take part like they're supposed to, or they don't perform like they're supposed to. Maybe it was a small thing where they warmed up with the incorrect outfit and they actually used their energy source more than they were supposed to. All these things play a role. So that's why we need to know about this. So it's necessary for normal bodily function. Furthermore, homeostasis is a regulation, a mechanism of regulation in the intrinsic part of the body. It's an automatic response on a cellular level. You're not sitting and thinking on it to do it. It's an automatic response. For example, hormones are released when you get a certain stimuli. Okay. Now you are a coach. You tell your person, listen, they're going to take part in the national championships, the South African championships, arm wrestling championships, for example. Now, immediately when they think that and they feel that, the stimuli that they get, the heart starts pumping faster. They start sweating a bit more because the body's preparing to take part in this vigorous activity or this event that I was training for all the time. That needs to happen automatically. If it does not happen and you do get individuals like that, They're at training, but they don't have that response, that bodily response when it comes to an event or taking part in an event. Then they don't perform at optimal level. Because the body's like, whatever happens, happens, I don't care. If I come first, if I come last, if I win, if I don't win, I don't care. And then what happens, they perform under the level, because winning for them is not a thing. This is usually what I call, when you see people taking part in events, they are the people, if you say, for example, they're going to run a 5-kilometer road race, those are the people that stand at the back on the 5-kilometer road race. Because they don't care about winning. They're not standing in front to win the race. That's usually like that. And you will pick that up as coaches as it goes along. Okay, homeostasis, how does it work? You get a receptor, a control center, and an effector. Okay, receives a stimuli, the control center processes that stimuli for interactions, and the effector carries out the instructions. For example, you're sitting in front of me here. Okay, imagine this, I've got a tennis ball in my hand, and I say catch, and I throw the tennis ball, you pick up your hand, you catch the tennis ball. Okay, that happened automatically. Imagine this, I've got a knife in my hand over here, I'm playing a knife, catch the knife. You duck away from the knife. It happens automatically. That whole receptor control center effect happened like this. He wasn't thinking, oh, knife, should I, what's happening in the knife hitting the face? It happens immediately when you say that. Now, on the field, you can work on these control effectors and effectors, receptor and effectors. Say, for example, you teach somebody how to do, not Formula 1 racing, because we don't really do that in South Africa, but go-kart racing, which is also really fast. You make one small wrong decision, you see, okay, there's a corner over there, so I need to head there, but I didn't look this way, and there's another car, you bump into them. That receptor, control center, effector responses, you can work on that, so they can actually have better tactics while taking part in a certain event. For example, I'm thinking of this one boy who ran this weekend. He did a 3,000 meter. He broke a record on the 3,000 meter, which is extremely fast. It's the second fastest time ever by a South African boy in his age. Then he did the 1,500. He won that event. He did the 1,500 the next day. He ran fast, but he came like 7th or 8th. And the difference was, he's not fast enough to win the other race. It's because of his receptor control center effectors that had an impact on his tactics while running. The 1,500 is a lot faster than the 3,000 meter. He won the 3,000 meter. Okay? He ran almost the same time for the 3,000 meter twice in a row than he did for the 1,500. But on the 1,500, if I'm running here, and this person all of a sudden starts accelerating, and I'm taking 2 seconds to accelerate and to respond, that person's got a gap of 5 meters on me, and then they beat me in the race. Whereas in the 3,000 meter, that person starts running, okay, now I can respond and I can catch up. Because you've got more time to catch up. So this, if you work on this in certain events, in certain sporting codes, soccer for example, the receptor, I'm looking at the field, that opponent says, it's taking so long to get this, I'm going to kick the ball there, I'm going to run here and I can score a goal. That receptor thing needs to happen so fast. The quicker it happens, the quicker you can incorporate certain tactics in your event, and the better you will perform. Okay, so this is this whole thing that I just said with the stimuli, receptor, control center, effector, is what we just explained. This is just in pictures now. Okay. Now, finally, how do you maintain homeostasis? The body communicates through neural and hormonal control centers. Everything happens on that hormonal level. Response to changes in the environment, the stimuli, whether it's hot or cold, we start sweating, not sweating, catching something, not catching something, running here, running there, whatever it might be, being aggressive while in your event, all those things. Sends information to the control center along an afferent pathway. Okay. And then that goes to the control center, thinks of what needs to happen over here, it analyzes the information, and it gives an effect out on what to do now. I'm running over here, this person starts accelerating. Immediately this response will be saying, I either go with or no, it's to shoot. And then if I go with, I can win the race. If I make the wrong choice, I lose the race, for example. It needs to happen like this. And in your sporting coach, when you coach one day, you can actually teach. There's certain field tests, field exercises that you can do on the field where it increases this response, the receptor effector response, where it can happen quicker. And if it happens quicker, obviously they can perform better. I mean, if we are on this field and me and him, for example, we exactly the same speed. I'm as fast as he is, he's as fast as I am. Both of us are strong. But we need to run to that ball. And I initially thought, okay, I see my teammate running over there, they're going to kick the ball, it's going to go there. And while I'm thinking that he already do that, and he starts accelerating before me, obviously he's going to get to the ball before me. And that increases performance. Okay, so everything that we just said, just on a table, you can read through it. I'm not going to read through it for you. It's really small on the board, but obviously you're going to have this in front of you, so you can just zoom in. Okay. Then you get a feedback mechanism, which is called a negative feedback, includes most homeostatic control mechanisms, shuts off the internal stimuli or reduces its intensity, work like an air conditioner. So, for example, this is internally, when I refer to internal stimuli. You start sweating. Now I'm cooling down. It needs to stop, so it sends out a negative feedback. Stop sweating. Then you stop sweating. That's what it is. It's like the opposite of increasing something. That's a negative feedback. Does that make sense? Okay. Again, don't need to detail on that. Everything that you already said. I'm not going to read through that picture for you. Okay, then a positive feedback increases the original stimuli to push the variable even further. Negative feedback, okay, I'm going to relax now, my heart rate's going to slow down. Positive feedback, I know I'm going to stand up and I'm going to run now. So the body's getting used to it now, I'm going to increase my heart rate, I need oxygen, and you start running faster. Okay. This is just an example of how your arteries or your veins actually increase if you get that internal positive or negative mechanism. Okay. Any questions? Anybody with any questions? Okay. People, this is unit 1. Okay. So now you have an idea what we're going to do this year. Okay. We're going to go into detail on all these things. Out of this unit, there will be some questions coming out of this unit as well. Okay. Because it's not for nothing. It's not just an introduction. Listen. What I usually do is before your test and so on, I actually do give you a scope. Okay. I didn't say this last week. What we do at the university, we usually book out a computer lab, and you write your test in the computer venue, behind a computer and all that. For this class, because it's a really small class, not a lot of you will sit here and physically write your tests. Okay. So that's for the test. The assignments will be handed in online on Moodle. On that day when you hand in the assignment, we'll still have a lecture. Unless I say, listen, people, we are far ahead, or we don't have a lecture this week, then we can cancel the lecture and move on to the next one. Okay. Or if life happens somewhere, or there's a public holiday, or whatever it might be. Okay, good. Sorry, I ran through that. Did you learn something? Okay. So I'm going to ask you what you learned, then nobody's going to say anything, so I'm not going to do that. Thank you so much for being here. Your stuff will be loaded onto Moodle. Don't look at the stuff that's on there now, it's not correct. So the stuff will be loaded onto Moodle. Just give it till tomorrow evening to do so. Okay? I have everything, I just need to load it on. And then when it's on there, you can have a look at that. You've got my email address, personal issues, email me. Otherwise, just go to your questions. Okay. Thank you for being here. Have a lovely week. And then I will see you next week again. Thanks.
Thanks. So before we leave, can we just...
Yes, sorry, question, yes.
So we've got a tutorial for this lecture tomorrow at 10:30.
No, okay.
So what's regards to that?
Thank you for asking. I actually forgot to say that. So currently for this module, we don't have any tutorials. Okay. When you keep that slot open for a possible tutorial, what I usually do is obviously you do your assignment, then you write your test. After that first test, if I see, listen, you're struggling, you're not getting the work, you don't understand, then we have tutorials. Otherwise, I'm not going to have a tutorial because then I say, you guys doing what I'm saying in classroom, there's no need to come in for a tutorial after that. Okay, I keep that slot open because maybe the second semester happens and you struggle with the work and we need a tutorial. Okay, usually for this module as well, I don't usually take more than an hour because people fall asleep after an hour for some reason. It doesn't matter what you discuss. If you even discuss whatever it might be, people fall asleep. Okay, so usually I keep you here for not more than an hour. But after that, if it was based on last week's work and you've got questions, ask me. Say, listen, I went through my work, I was studying, I don't understand this, please give me advice. Ask me. If I'm not here and you still need to ask me, my office is just up there. Send me an email, have a meeting with me, we can chat. Or come to my office. If I'm in, I will be able to see you if I'm not busy. Okay. So for now, tutorials not necessary. Anything else? Okay. Good people. See you next week. Okay. Thank you, Liam.
Thank you, sir.